What's that?
Well, because I'm trying to do the registration for the class here,
Okay.
and it mentions the petition, and I don't know if you know when, because it says the exceptions begins May 13th, but I don't know if that means I have to wait till May 13th to submit, because I don't see any form here.
Go back up. Is that a link right there?
It says they open May, but it doesn't really say when. Because I emailed the professor for the syllabus, he sent me it, but he
Yeah.
was like, "Oh, the section that I wanted to get into is already full."
Oh,
So
really? Okay.
I'm like trying to see if
Um,
I'm missing something because I'm
yeah,
pretty
I'm
sure
not familiar with their
no,
processes. Is there like an email you can contact, like at their general scheduling office or
I
something?
think yeah, I'll probably end up
That's probably the
yeah.
best thing to ask. Yeah, because I'm not familiar with
Yeah,
their
they still have a
process.
section open, but I want to like make sure I get into
Yeah,
there.
no, for sure. Yeah, I would try to send them an email.
Mhm.
Yeah, because the professor usually is in charge of
Yeah.
scheduling, and so yeah, if there's an email at Calpite Money, you can contact there. That would be the best.
Alright, thank you.
Yeah.
Also, since he sent me the syllabus, should I just fill out the course equivalency now, or should I wait till I like actually?
You can throw that out now.
Okay.
Yeah, yeah. The syllabus is the main thing you need for that. So
Not sure which one of the forms you're gonna be grading,
Mhm.
but since we're doing regression analysis and correlation analysis, and this one, does that mean we probably get away with having that question wrong?
Yeah, there's no way for me to verify. I'm not gonna go to all these videos and verify that. I'm mostly looking either problem 2 or problem 3.
Okay.
Yeah, so that one I could actually verify your process a bit better in terms of how you either, compute the confidence intervals or test the hypothesis.
Got it.
That's what I'm more looking for. Yeah.
That makes sense. Yeah, I just remember seeing that question.
I also can't verify your heart rate, and so I can't verify that accuracy too. Someone asked me that in office hours today. I'm like, yeah, there's no way I can check. It's like, can I do it for my friend? Like, yeah. I mean, I don't know what your resting heart rate is, so I'm not checking that. I'm checking if you did the confidence process.
Yeah, she started saying a bunch of stuff. You better stop. Yeah, no problem. Yeah, that's fine. The Indians, we did the. So. Yeah. I know. Don't know. I think I should have 3 times with them.
All right, it's 4 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today?
Good. All right.
Good. I'm good. Excited for the end. I'm sure you guys are. I'm probably sure you guys will be more excited after the final. Okay, so today's our last I guess real lecture. So today's the last day I'll be covering new content. So as promised, on Thursday will be just the final review session. So there will be no new content on Thursday. We'll just be reviewing for the final. Okay. Speaking of the final, hopefully everyone got the email last Friday about the poll. So I put a poll out on Canvas for you to vote on the topic that you would most like to see covered in the final review session. So there's, like I mentioned before, there's 4 main topics that are going to be on the final exam. It's going to be first order ODEs, Laplace transforms, Fourier transforms, and all the probability and stat stuff that we're covering in the last couple weeks. And so whichever one you kind of feel most uneasy about, or the one you feel like you need a refresher on, please vote on that on the poll online, just to make sure I cover it on Thursday. Okay. I'd love to cover all of them on Thursday, but I think, you know, if I do want to give it justice, then I do have to kind of limit it to just, you know, probably the top 2 topics from the poll. So please make sure you vote on the poll, just so I kind of know what to cover for Thursday. So the poll is going to close tomorrow at 11:59 p.m. So if you haven't voted on there yet, you know, go vote. It's not graded or anything, but you know, it's, you know, usually democracy is better when everyone votes. And so, you know, please make sure that. Okay. Final exam is going to be a week from today, and so it's very quickly approaching. So final is going to be on Tuesday, May 12th. Okay. Time is going to be at 5 p.m. Okay. It's a 2-hour exam, and so it's going to go until 6:50 p.m. And the room is going to be our current one right here. So it's going to be ESE 022. Okay. Okay, so please mark your calendars. You know, if the scheduling system is working as intended, you shouldn't have any conflicts. Although if for some reason you can't make it to the final exam, please let me know as soon as possible. You know, I know there's some legacy teams that are traveling next week as well. And so, you know, if you're not able to make it to the final exam, please let me know. We can make arrangements for you to take the final at an alternate time. Okay. In terms of what you can bring for the final, you know, same deal as the midterm exams. So please bring your writing utensil. Please bring a calculator. You can bring 2 cheat sheets this time. And on both of those sheets, you can put notes on both sides. Okay. So I guess you can say there's 4 total sides of notes that you can put on. Okay. So I'm allowed to, just because there's more content on the final than there are on the midterms, and so you should have more notes. Okay. But yeah, I think that's about it. Any questions on the final exam, what's going to be covered, or just kind of anything before the class today? Okay. All right. And so, you know, make sure you're also checking out the study guide as well. So study guide has all of the conceptual and problem solving topics that you should know. And then, yeah, so I've office hours. Well, so I had 2 office hours this week already. My last office hours this week is going to be on Thursday, 1 to 2. I will have office hours next week during my usual times. Should probably mention that as well. Right, so even though we don't have class next week, you know, I do want to have office hours just to kind of give you a chance to ask questions. And so the office hours next week that'll be most relevant for you guys will be Monday and Tuesday, 2:30 p.m. to 3:30 p.m. Okay, so those I'm still holding those regularly. I don't believe I have any conflicts. No, I haven't scheduled anything for those. So yeah, I'll be there for next week as well. So, you know, if you have any last minute questions or last minute help that you need, you know, you can come to office hours next week as well. Okay. Okay, all right, and so with that, we're going to get into the final topic for the class, which is regression analysis. And so this is the topic that you need to do the very last problem in homework 7, which is the YouTube you know, video comparisons. And so I saved this one for last just because, you know, in terms of, you know, actual work that I expect you guys to do, there's not much, you know, this is not something I can really test you on an exam, because you know, you can't really make a trend line on an exam without like a spreadsheet program. But, you know, I would still be, you know, I would still pay attention today, first of all, because even though, you know, I'm not going to ask you to make a trend line on the exam, I might ask you a conceptual question about this on the exam. So So I think for today, it's going to be mostly focused on concepts. If we have time at the end of the day, I'll show you how to make trend lines in a spreadsheet program, although I'm sure probably a lot of you have made that already. So today's going to be more just kind of the theory of trend lines and kind of what to look out for those topics. Okay. Okay. All right. So let's go ahead and get started. Okay. So today, our topic is linear regression. Although I think kind of what people know this better for is we're just making trend lines. Okay. So, we've spent the last few weeks, covering probability and statistics. By no means is this a comprehensive, coverage. We're kind of dabbling in certain topics that I think are important for you guys to know. But everything that we've covered so far, we've essentially only looked at one random variable at a time. Okay. So when we did, even just initially, right, we were just introducing the idea of a random variable. Then we talked about confidence intervals. Then we talked about hypothesis testing. These are all techniques for basically measuring and quantifying the uncertainty in one random variable at a time. Okay. So that's great. And so, that is, a lot of what we covered will get you pretty far in terms of, analysis of these types of situations. But in reality, a lot of times we're interested in not just one random variable, but maybe relationships between different random variables. Okay. Because oftentimes, if you have an engineering system that you're trying to analyze, or even just a situation in your own personal life, right? There's multiple factors that could be, that affect one another, and we want to find out what the relationship between them is. Okay. Okay. So the most common way to kind of and to perform this analysis and to visualize the results is to use what's called a scatter plot. Okay. So I'm sure you've all seen a scatter plot before, maybe not in your academic setting, but somewhere at some point, right? So a scatter plot is a plot that looks like this. Okay. There's a variable that we're going to plot on the horizontal axis. So for lack of a better term, I'll just call it variable 1 on the vertical axis. Okay. We'll call it variable 2. Okay. Sometimes one of these variables will be a non-random variable, will be a deterministic variable. Sometimes they're both random variables, so we'll discuss kind of the difference between that. Okay. But basically, what the scatter plot will show you is that, when variable 1, or when one of your variables holds a certain value in a given situation, then variable 2 will have another particular value. Okay. So each point right here, right? So, the way that I think people view these is, there's multiple points. Okay. For now, they don't have to be in a particular pattern. I'm just kind of illustrating what a scatter plot looks like. Okay. So each point in a scatter plot there represents one observation. The observation of, the value of variable 1 and the value of variable 2 in a given situation. Okay. All right. So the idea with the scatter plot is that, by plotting the data in this format here, any kind of relationship or any kind of, rules or ways that these two variables are connected is going to come out clearly in a figure like this. Right. Because with the scatter plot, there's a lot you can do with the scatter plot, and so on. Just naively, right? Just looking at a scatter plot, you can often pick up some trends. This particular one that I drew here, there's not really a trend there, although you can kind of see maybe there's an upward trend. But you can also do things like compute trend lines or perform what's called linear regression, which we'll get to later. Okay. So let me give you a couple examples of this, right? So when I say there's a relationship between variables, it's not just any kind of random relationship. Usually that relationship is governed by some kind of, equation of physics, some kind of, natural kind of law that these phenomena will follow, right? So for example, maybe we're interested in, the relationship between, how long it takes for a particular water droplet to evaporate. So that might be one of the variables that we're interested in versus, maybe the initial size of the droplet. Right? Okay. So this kind of, this kind of notation here, we have one variable versus another variable. It's not like these two variables are fighting each other, right? It's just that's just kind of how we compare them, right? So in this case, the initial size of the droplet, that would be one variable. So maybe that's our variable 1. And then our other variable here, the evaporation time, this might be variable 2. So generally what you expect is that, maybe bigger droplets will take longer to evaporate because there's just more water to evaporate. But the evaporation time is not something that's random, right? So that's governed by, maybe the temperature in the room, maybe the air pressure, surface tension of the water, things like that. Okay. So by visualizing these relationships in a scatter plot, we can start to pick out, maybe there's a relationship between these two that's governed by the physics. Okay, so that's just an introduction to scatter plot. And so what we're going to get into next is, the different types of analysis that you can do with scatter plots. Any questions on this so far? Okay. All right, so there's generally, I would say, kind of two different types of analysis that you can do, right? They look the same, right? So it's not that they make the scatter plot look different. It's more in terms of how you interpret the results. All right, so the first type is what's called a regression analysis. So in a regression analysis, only one of the variables that you're plotting in the scatter plot is assumed to be random. The other variable is a deterministic variable. So the deterministic variable in this setting here, usually we call this the control. So the reason we call it the control is that we have, more or less kind of direct control over that variable where there's kind of no uncertainty in its value. Okay. And the other variable is the random variable, which we often call the dependent variable. All right. So the goal of a regression analysis is to determine or analyze how the dependent variable, how its value changes or depends on the control variable. Okay. All right. So in a regression analysis, you usually have direct control, or you have, exactly the value of one of the variables. There's no real uncertainty with that, but the other variable may be dependent on it. Okay. So let me give you some examples, right? So remember visually, when you look at scatter plots for either a regression analysis or the next analysis we'll go over is a correlation analysis, they look the same. But how you interpret that and what the scatter plot's actually telling you will depend on whether it's regression or correlation. Okay. So let me give you an example here. So oftentimes, one thing that's interesting from a medical standpoint is, how a person's average blood pressure changes with their age. So generally speaking, as a person gets older, especially once they get into kind of their more senior years, 50, 60, 70, blood pressure tends to go up, right? It's not an exact science. Of course, it depends heavily on your lifestyle choices as well. But that's generally the trend that we see. Okay. So in this situation, the age here, this would be our control variable. Not that we have direct control over people's ages, but there's generally no uncertainty in someone's age, right? So we can look up we can check their birth certificate. We can see exactly when they were born, and so there's really nothing, there's no uncertainty there, and you can't really affect your age. Your age is just the amount of time that's passed since you were born. Okay, so the age is something that we generally assume that we know exactly, right? So there's no need for us to put that as a random variable. But the blood pressure, this right here is our dependent variable. Because that has a lot of uncertainty, right? And so, for any individual person, their blood pressure, we're making the assumption that it depends on age, but it also depends on a lot of other factors in their life as well, right? So lifestyle choices, diet, exercise, things like that. Okay. And so in a regression analysis, you're not really interested in the control variable. The control variable is kind of just there to show the relationship, but really the one that you're actually interested in is what is the dependent. And so in that sense, when you have a regression analysis, you really only have one variable that you're really looking at, right? And so in that sense, it's not that different from our confidence intervals and our hypothesis testing because we only have one random variable, right? The other one is just our control. Okay. The difference here is that with a regression analysis, you're going to have multiple data points at different, under different scenarios. Okay. That's really the only difference. So, when you're doing confidence intervals, hypothesis testing, we're really only looking at our random variable under just one scenario. But with a regression analysis, we're looking at under different scenarios. Okay. And maybe there's no relationship, right? And so maybe you do a regression analysis and you find that your dependent variable has no relation at all with your control variable. And that's fine too. And that's something that's actually very common. Although, I think people are reluctant to admit that sometimes. We'll talk more about that in a bit. Okay, but regression analysis, it's a single variable analysis. We're just looking at it under different scenarios. All right, any questions on regression analysis? Okay. All right, so let's go through the second type of scatter plot analysis. So the second type of analysis is known as a correlation analysis. And so in a correlation analysis, unlike regression, both variables here are assumed to be random, or they're assumed to have uncertainty. Right. So usually you're going to do a correlation analysis when you're just taking observations of a phenomenon kind of in the wild. And so just whatever value each variable happens to be, you're just taking an observation. Okay. So usually when you do a correlation analysis, it's under less how should I say, under less controlled situations, right? And so usually you're doing a regression analysis when you're doing a very intentional, very explicit experiment, usually, right? So a lot of times when you're doing your lab reports, when you're doing experiments, most of the time you're going to be doing regression analysis because you're controlling for one of the variables and you're seeing how the other variable is going to respond. Okay. Correlation analysis is more that you have just random phenomenon that are kind of happening out in the wild, out in real life. you're making observations, you're taking measurements, and you're trying to see if there is a relationship. Okay. And so whenever you see a scatter plot, and you will see scatter plots, and so if you read any amount of scientific papers or lab reports or journal papers, scatter plots are very common because they're a great tool, right? And they're honestly really something really nice to visualize these types of data. But you should always ask yourself the question, is this a regression analysis or is this a correlation analysis? Because that kind of changes your perspective and how you kind of view, first of all, how that data was obtained, and what kind of conclusions you can draw from that data as well. Okay, so one important thing with correlation, it used to be kind of a very trite kind of saying, but the saying always goes that correlation does not imply causation. I think typically that's a law term, so I think you hear it more from lawyers or in the courtroom, but it's true for science as well, right? So for correlation analysis, this statement is very important. So it is very possible that maybe you take observations of some kind of phenomenon, you see some kind of correlation. There could be a relationship there could be something that's causing that correlation to occur. Okay, but you can't. But just based on a correlation analysis by itself, you can't make any statements or you can't make any definitive statements in terms of that this phenomenon is causing this to occur. And so you see this a lot, when if you read the news to any particular degree, you see people are always trying to use data to kind of further certain agendas and certain kind of conclusions and viewpoints, right? But you'll see that people, when people report things, just so that they don't get in trouble, they say allegedly shows this thing, or this data implies that this is occurring, right? So they kind of say that part very quickly, just so that you kind of ignore it and you kind of kind of believe what they're saying. But it's true, right? And so just because the data kind of shows that there's a relationship, that there could be, doesn't necessarily mean that there is one. It just means that maybe we have to study this further to see if there is something important there for us to look at. Okay, so that's really important. Whereas for regression analysis, right? Usually when you're doing regression analysis, you're doing it very intentionally to see if there is a relationship between these two variables. And so you control one variable and you observe the other, right? And so a regression analysis, you can make the argument that it still doesn't argue causation because it doesn't show any kind of underlying mechanism for this to occur. But I would say it's at least a stronger statement, a stronger piece of evidence than just correlation analysis. So that's that's an important point I want you guys to kind of take away from this, is that be very critical of data, because data is abused a lot in general. And so whenever you see data, whenever you see plots, always kind of be critical in terms of what are you actually looking at, how was this measured, does this actually say the things, or does the conclusion, does that actually make sense from this data based on how it's taken. Okay. Okay. All right. Any questions on this so far? Okay, good. All right, so now that we've kind of introduced, the different types of scatter plot analysis, let's talk about what we can actually do with it. Okay. So the most common thing that's done, because sometimes looking at just a plot with a bunch of points in it is not. I mean, sometimes it's clear, but a lot of times it's not. Right. So in order to make this analysis a bit more digestible, usually a trend line is added to the data to make things a bit easier to interpret. So let's talk about trend lines. Okay. So the idea or the goal of a trend line is to take data from a scatter plot, whether it be a regression analysis or correlation analysis, and start to actually quantify, what the mathematical relationship is between these variables. All right. So there's different types of trend lines that you can make, right? It kind of depends on how the data is correlated with each other. We're going to talk about the most common trend line, and this trend line is also the easiest to interpret, which is a linear trend line. Which basically takes your data and then tries to fit a simple linear function that tries to pass through as much of the data as possible. Okay. And so if we look at a scatter plot again, right? So we have variable 1, variable 2. Right? We have a bunch of points here. Right? So a trend line, we'll look at these points, right? And so, maybe there's not a definitive relationship, but we can say that, if we draw a line, maybe something like this, right? We can say that that most of the data is following this type of relationship between them all. Okay. Now, most of the time it's not going to be exact, right? You're not going to have every single data point sit directly on the line. Most practical cases you're going to have some scatter from the data in the trend line, just like you see here. Okay, but the idea is to try to make one that passes through as much of the data as possible to try to start making some conclusions, right? Because based on the slope and the y-intercept of this trend line, that's going to give us some information about how these two variables may or may not be mixed. Okay. So computing a trend line, technically you can do it by hand, but it's usually not a fun exercise to do. Usually you're going to rely on some kind of spreadsheet program to do it for you. So either Microsoft Excel or Google Sheets is the most common. Okay. So again, you know, I'm not gonna ask you to make a trend line on the exam. That's just kind of cruel and unusual. But you know, it is important to kind of know, you know, a little bit in terms of how they're made. So we'll discuss that in a second, but also just how to interpret the trend lines as well. Okay. So the way to interpret the trend line is the following, right? And so just like any kind of linear line, it's defined by its slope and its y-intercept. Okay. So the function is usually given by something here. Okay. For x, this is the value of one of our variables. So in this case, it'll be variable 1. I should say this is equal to y. So y, this is the value of variable 2. Okay. And then of course, k0 here, this is our constant. So this right here is our y-intercept. Okay. And then k1 here, this is our slope. Right, so the y-intercept and the slope tell us kind of different pieces of information about how these two variables are. Okay. All right, so let's go through each of them. Okay. So let's go through k0 first. Okay, so k0 is the y-intercept. So you know, just based on algebra, you know, I think everyone kind of knows what the y-intercept is. So when your variable 1 has a value of 0, k0 tells you the value of variable 2. Okay. So oftentimes in probability and stats, we call the y-intercept, we call this the bias in the data. Okay. So more specifically, it's when it's the value that you obtain when variable 1 has a value of 0. Okay, so depending on what you're measuring, right? So depending on what that variable 1 is and what variable 2 is, sometimes the bias is very important because you know then it'll show you kind of something interesting about the data. But sometimes the bias is useless, and sometimes you don't care about the bias. Okay. Right, so it's sometimes important, and that's one of those kind of vague statements where you know I may as well not write it because you know that doesn't tell you anything. But let me give an example. Okay, so let's look back to our previous example of you know let's say we were interested in the relationship between blood pressure and versus age. Okay. So our bias, so we do expect a bias in this data. I don't even need to look at the data to tell you that. Okay. Okay. And why is that, right? So when you're first born, when you're a baby, you're at age 0, right? So generally we expect babies to have some blood pressure. They don't have 0 blood pressure because they're not born. Okay? So in this case, the bias is, maybe we don't measure because, most babies don't have their blood pressure measured right when they come out from the womb. But the bias is what we expect the blood pressure of a newborn baby to be. Okay. But of course, that's assuming that blood pressure follows a linear trend, right? As we age, which I can also tell you is also not true. So blood pressure does not generally increase linearly. It's kind of more of an exponential curve. It kind of really ramps up when you start to get really. Okay. But regardless, regardless of the trend line, I do expect a bias in the data because that just makes physical sense. Okay. Okay. So bias, sometimes you're interested in it, sometimes you're not. It kind of depends on the situation. Okay. The slope, K1, right? The slope is often what we are almost always interested in when we're doing a scatter plot, because this tells you, the relationship, the multiplicative relationship between variable 1 and variable 2. Okay. Right. So almost always on a trend line, you're going to be making note of the slope to some degree. Okay. Because that's the main piece of information that tells you how the variables are connected, which is the whole point of making the scatter plot to begin. Okay. Okay. So for linear trend lines, there's not too much to discuss here. It's literally just these two values here, but just from those two values, you can get a lot of information. Okay. Now, if you're going to be using other types of trend lines, and so I think in Excel, you can make a quadratic trend line, you can make an exponential trend line, a logarithmic trend line, right? So those are going to have different parameters. Okay. And so what those parameters are telling you will actually tell you a lot about how these two variables are connected to each other. Now, this is the part where it starts to get really interesting because, oftentimes when you're measuring scientific phenomenon out there in the wild, right? You know that there is a relationship between two variables, but you don't know how they're related. Okay? And so the operative keyword in this statement is how. Okay. So for example, right? So the next step up from a linear trend line is a quadratic trend line. Right? So quadratic trend line looks something like this. And so we have K0 plus K1x plus K2x squared. Okay. Right. So we have three variables to compute here. Okay. Now, depending on the relative magnitudes of the different K variables, Specifically just K1 and K2, because K0 is just the bias, so the bias doesn't really tell us too much a lot of times. Okay. So depending on which of these parameters are larger, will tell you kind of the stronger dependence or the stronger relationship between these two variables. Okay. So you hear that terminology quite a lot. And so, you can see you'll hear that, two variables are exponentially, in my mind said exponentially, it should be quadratically, excuse me, sorry. We didn't cover exponential here. Right. So let's say K1 is very strong. So K1 has a very high magnitude, K2 is very small. So that means we have a very linear relationship between these variables, right? If K2 is very strong, but K1 is very small, then we say that these variables are quadratically linked, okay? And then depending on the type of trend line that you have, you might have a logarithmic, relationship, it might be an exponential relationship, right? You can just gauge by the relative magnitudes of these parameters how strong that dependence is. Okay. All right. Any questions on this so far? Okay. So I'll only just briefly comment on it, just because you typically are never doing this by hand. But usually the way that a trend line is formed is it uses a method called least squares. Where basically the idea with least squares is that, the idea is to make a trend line where the square of the distance between the trend line and each individual data point is minimized. Right. So there is a very systematic way to do this. It's not something that you do by hand. It is a computer algorithm, but is a very established, methodology. Okay. All right. So last thing I want to talk about today is how do we assess trend lines? Because sometimes you might have good trend lines, sometimes you might have bad trend lines. And so it's kind of important to kind of differentiate between the two. All right. So when you're making a scatter plot and when you're making a trend line, the hope is that your data or your variables are very tightly correlated with each other, right? So when variable 1 has a certain value, variable 2 has a certain value, and there's kind of very little uncertainty between those. Okay. So, I think you've all seen what a good trend line looks like, but just to kind of remind you, right? So let's say that our trend line for this particular data set goes like that, okay? Right, so if the data here is very closely related, most of the data points should be kind of very clustered around the trend line itself, right? So you might have a lot of data points, there might be some scatter, right? You might have some data points that are right on the trend line, right? But some scatter is usually okay. But for the most part, you can see that all the data points kind of cluster around here. So this right here is a good trend line. Or I would say, maybe saying a good trend line is not maybe not the right way to describe it. Right? The trend line is just the least squares. The trend line is not doing any crimes here. But I would say, this is a strongly correlated, two variables. So something like this, if you see a scatter plot like this with the trend line, which is very clear, usually you can start to draw some conclusions for this, especially if it's, if it was done by linear regression. Okay. These weren't just random observations. This was a very intentional way to kind of see a relationship between these two. Question is?
Yes, for the correlation, let's say this is a correlation analysis. Does this serve as evidence to demonstrate that it's not so random?
It could. I'd say this is the starting point. So this, I think, would open the conversation. And so, having observations like this for a correlation analysis said that, these two variables, they seem very strongly correlated. So maybe we should investigate it further. Maybe let's do some experiments where we actually control one of the variables. Let's see if we can reproduce this. But it's not enough to say that that variable one is causing variable two or vice versa. I wouldn't say that.
Circumstance.
Exactly. Yeah. Because with correlation, usually the setting in terms of how a correlation analysis is done. Usually there's other variables that could come in and affect your data as well. And you want to make sure that you're not measuring those other factors. You're only measuring these two. Yeah. Okay. But on the flip side, you may have a scatter plot that looks like this. Okay. Right. So just because your variables are not strongly correlated doesn't stop you from making a trend line. You can always make a trend line, but you have to kind of be critical in terms of maybe these variables aren't exactly correlated with each other. All right. So maybe you have some data. You produce the trend line, looks like that, right? But the data itself, looks something like this. So your data is just kind of all over the place. Right. So this would be a situation where, I would say that, yes, you drew a trend line, but this data does not imply any correlation at all. So going back to a comment I made kind of earlier in class today, when in the world of academia, where everyone's trying to publish data and kind of trying to make like new discoveries, everyone's trying to find correlations or a relationship between variables. Especially in the medical field. So in the medical field, people are always trying to say, if you do this lifestyle change, then it's going to lead to this, right? Because that's where kind of a lot of the big bucks are. Then you usually can develop a drug, sell a lot of money, right? So that people are always trying to find things to do this. Or correlations to make. But I would say that a lot of the times the data does not really support the conclusions that they're trying to make, even though they try, right? So a lot of times, you'll see papers and honestly very highly respected medical journals that look something like this. And they'll try to make the argument that, that these variables are connected, but, if you just look at that, then it's not. I remember one time I was in grad school, and then I was attending a seminar for a doctor that was showing data like this. And then, I made a comment that said, I don't think that's correlation. I think you just took a Sharpie to a Chips Ahoy cookie. That's kind of what it looks like to me. So he did, the presenter did not appreciate it. My advisor thought it was funny, but she also thinks that it was probably not professional to say like that. So that's probably why people don't like me. So. Okay. So how do you know, right? So, visually, a lot of times visually you can kind of see something like this, obviously not a strong correlation between these two, but a lot of times, you're not going to get data that kind of fits into these two archetypes here. You're going to get situations where it's kind of in between, right? So there is a way for us to measure how strong a correlation is on a trend line. Okay. And so again, this is probably something that you've looked at before, but maybe didn't know the exact definition, which is the R squared value. Okay, so R squared is a very simple metric. So any self-respecting spreadsheet program will be able to compute R squared for you, right? And so I always recommend this. And so whenever you're using spreadsheets to make correlations, trend lines, always compute R squared. Okay, so R squared is actually a ratio, and so it's a ratio of what we predict the variation to be based on the trend line. The variation is just how much scatter or how much range there is in the data. Okay, so we can get a measure of that just directly from the trend line, so just independent of the data, right? And so the R squared value is the ratio of that over the actual variation that's given from the data itself. So the numerator here is a metric that's produced just from the trend line, so independent of the data, and the denominator here is a metric that's computed from the data, independent from the trend line. And so the closer these two match, the stronger your trend line or the stronger correlation there is between your variables. Okay, and so generally the R squared value varies from 0 to 1 because it's a ratio. Okay. Where an R squared value of 0 means that there's no match between the prediction and the actual data. And an R squared value of 1, this is, total matching or complete matching. Right, so R squared values that are closer to 1 are obviously more preferred, right? So that shows the strong relationship between your variables, right? But then the question is, how high do you want it to be, right? So is R squared value of 0.7, is that good, or 0.8? And so I would say, if you're going to make any kinds of conclusions from your data, whether it be regression analysis or correlation analysis, you want your R squared value to be at least 0.9. Okay. But I will temper that and say that is my own personal opinion. Even I would say 0.9 is if you did your experiment properly, 0.9 is not that hard to get for a trend line. You know, unless there's no correlation. If there's no correlation, then your R squared is going to be 0.5 or something like that. Okay. So, but in my opinion, if you're going to make any kinds of conclusions or you're going to make any kinds of analysis, the starting point is R squared of 0. Okay. Now, if it's not there, but you do expect there to be some relationship, right? Then maybe there's an issue with how you measure your data, which is possible, right? But that's not a bad thing. That's maybe you just have to go back and collect some more data. But I would say just to start the conversation, if you're going to be using scatter plots, trend lines regression, is that your R squared should be at least 0.9. That is my. Okay. Any questions on this? Yes.
What is the predicted variation for the trend line? What is that?
Right. So variation is basically, how much variation you observe, from the smallest point to the largest point.
Oh, okay.
Exactly. Yeah. So the more variation that so variation itself is not a bad thing. So, if you have strong variation, it just means that, one variable kind of changes a lot compared to the other. That by itself is not bad. But the R squared is saying, how much can we predict that variation versus how much variation there actually is. Yeah. It's not as simple as just taking the max versus the minus the min. That's not exactly what variation there. The calculation is a bit more complicated than that. But generally that's what it's trying to do. All right. Any other questions on this? Okay, it's a bit early, but I want to say this before today, just because on Thursday I'm going to forget. But I just want to thank you guys for a great semester. I will admit I'm getting like 3 or 4 hours of sleep, so I'm like half asleep most of the times when I'm coming to class. And so I know I've been kind of I talk and I'm like, okay, I said that already, so I know I haven't been here completely the whole time. So I just want to thank you guys for being patient with me this whole time. Thank you guys for being a great class. I'm saying this now just as Thursday. I'm just going to be just doing a review session the whole time. I don't want to take out any time to give a heartfelt speech. And so thank you guys. And so it's been a great semester. Hope you guys enjoyed the class. And yeah, I will see you guys Thursday for the review session and next Tuesday for the final.
So they got a good office hours.
So this is what I'm talking about, right? So I'm in 3, 6, 17, but technically I'm in 3, 6. I think I'm only in 12 because I'm on the wait list.
Oh, I see.
Yes.
Oh, well, you're trying to add
combustion, right?
Okay.
This is the maximum number that's allowed for this. For the ball.
You should be able to do 8. I thought 18 was the max.
Yeah.
I think look it up real quick, actually.
I looked it up too. It didn't say 18. I mean, it said I could take 18 minutes.
None of your courses are, there's no labs, right?
Let's see.
You too, Anthony.
Just design projects.
Yeah, but they're all 3-unit courses, right? 3.
Yeah.
Can you show up with it? So are you you're trying to roll in 2, right? Or just
Oh, so
it might be trying to enroll in both. I'm not sure. But maybe if you drop the circuits lab from your shopping cart, you might be able to pick up the combustion.
okay.
Yeah.
For sure.
Thank
you.
Yep.
I was just curious, do you have office hours on Thursdays?
Yes. Yeah. So Thursdays 1 to 2. Yeah.
See you there.
Yep.
was gonna ask what classes you're teaching next fall.
I don't know yet. I'm likely gonna be teaching fluids just because we just don't have a lot of fluids staff anymore. So I'll be probably teaching at least one section through third. That's my prediction. Usually I also teach the finite element class in the fall 2 to 410. But I didn't teach it this year, partly just because I was gone in the fall.
Oh, yeah.
But then this semester, I think, I always forget his name. Garavi, I think, is teaching the finite element. So I don't know if he's gonna teach it again in the fall.
Okay.
But yeah, there's a big demand for thermal fluids faculty. Right now it's just me and Dr. Banks.
Oh, really?
And so we have to figure out thermo and fluid between the two of us. But Dr. Banks usually teaches more thermo, and so I'm probably going to be teaching more of the fluids.
Okay.
Yeah.
Would I go for tech electives too? You think you teach it?
So 410, the finite element is a tech element. Besides that, I don't think I'll be teaching more than 410.
Okay.
Yeah.
All right. Thank you.
Yeah, no problem.